Okay, we are at the last question, question 14. So for question 14, we are given antimony Sb is in group 5. So based on this, we know that it has 5 valence electrons, okay, of the periodic table. So it forms a series of salts which contain this ion SbF5N-, and the structure is a square-based pyramid. So based on this structure, you are supposed to deduce, number 1, total number of electrons around the antimony atom, okay, the value of N, what is this value, okay, as well as the oxidation number of Sb in this ion, okay, and they tell us that it's square pyramidal. So for usual questions, we are required to draw this ion, but now they draw the ion for us and expect us to find out N. So very simple, we just need to work backwards. So how do you work backwards? Well, of course we start from the shape. Square-based pyramid actually is just our square pyramidal, and in this case square pyramidal, we know that it must have 5 bond pair and 1 lone pair. So we use this on the diagram. I have 1, 2, 3, 4, 5 bond pair and 1 lone pair. So my lone pair definitely must be here. Correct? So based on this, we can easily determine the total number of electrons in the atom. Okay, so for you to write down 6 electron regions around the central Sb atom. Please take note, central Sb atom, and it consists of 5 bond pairs and 1 lone pair. So since that's the case, we have 2, 4, 6, 8, 10, 12. Altogether, 12 electrons around the central antimony atom. So this is simple. So we have tackled our first question. Moving on from here, they want the value of N. Okay, so it is very simple. You notice antimony is from group 5. So since it is from group 5, and I already used up 2 valence electrons, that means antimony will need to do this. 1 electron, 2 electron, 3 electrons. So you notice I have already used up 5 electrons. So that means for these 2 bonds, it must definitely be a dative bond, okay, from fluorine to antimony, because antimony has no more valence electrons to form bonds. Okay, the 5 electrons have been used up in this manner. 1, 2, 3, 4, 5. So we know that every time our electronic configuration, for example, if we have 8 electrons, we will form dative bond. So that means this fluorine and this fluorine must have 8 electrons, okay, which is equals to 7 plus 1 electron. So that means this 1 electron must be from the charge. Okay, that means it must be 2 minus, okay, because each fluorine atom will take in 1 electron. Okay, fluorine is the more electronegative atom that will take in the extra electron. Okay, so that means N is 2 minus. Okay, so we can go on to the next part of the question, the value of N, but for you to write down in proper, Sb belongs to group 5, so it has 5 outermost electrons, of which 2 will make up the lone pair, which we already mentioned. So that means the 3 remaining electrons is used to form 3 single bonds with F atoms. Okay, and since there are 5 F atoms, 2 of them must have formed dative bonds with the central Sb atom, and these 2 F atoms must have 8 electrons. Okay, and which means that each of these 2 F atoms have 1 extra electron each. Hence, overall charge on the ion must be 2 minus. So this one, I have already gone through with you the thinking process using this diagram. Okay, so we can actually move on to part 3 of the question now. Okay, we tackled part 2. Move on to part 3. Oxidation number of Sp in this ion. Well, this should be very simple as well, because we know N is equals to 2. So we can just let X be the oxidation number of Sp. So in this case, SbF52 minus. So in this case, let it be X. Over here, each fluorine is -1. So we have 5 of them altogether, -2. So solve the equation. X should be equals to +3. Okay. Please take note in this part. If you are to write the oxidation number, you must always include the positive sign, okay, and put in front. Okay, it must be in front. So what are the 2 types which won't gain any credit? Well, if you write 3 on its own, it will be considered wrong. If you write 3 plus with the plus at the back, it will also be considered wrong. So in this case, well, just stick to the convention of having the plus sign in front, and then this will be taken as correct.